I welcome you all to the session of engine system and performance, and today we shall discuss about the ECU. We have already studied about this, that is electronic control unit or engine management system, but today we shall discuss about the key role of this particular unit, and then in this context we will see the key element of this unit as well. So, you know that for the ECU, the heart of an ECU is the microprocessor or CPU. So, microprocessor or CPU is the heart of electronic control unit, and this CPU or microprocessor is a solid state device that controls the information flow to the computer, and a set of information is designed into this microprocessor to tell it what to do. Following this program, that is the set of information which is also called as program, designed into this microprocessor as I said, and following this program, microprocessor performs calculation and then takes a decision to do certain things. So, today we shall try to discuss about this particular unit or element of electronic control system or engine management system, and then we will see how does ECU give output to several parts of the engine components receiving some signals from the sensors. So, as I said you that following the program, microprocessor performs calculation and takes a decision on what to do, what should be the output. So, if we now look at, rather we shall try to draw key elements of ECU. If I write key elements of electronic control unit, if we draw, so as I said you that microprocessor is the key or heart of the CPU, receiving some inputs, signals, right. It will give some output, but let me tell you one thing, microprocessor cannot store data or information. So, this microprocessor cannot store data or information, but receiving some input signals, typically those signals will be coming from different sensors and those are electrical signals. Microprocessor should do some calculation and then will take a decision what to do next. So, microprocessor is designed with a set of information and which is also known as program, that is what I said few minutes back. So, this microprocessor is having as I told you that microprocessor cannot store information or data. For making decision, so that is output, so it is decision. They need some this particular unit, the key unit of ECU microprocessor needs access to a great variety of information or data, because microprocessor cannot store information or data, and those information and data are stored in these two memories and rather chips. So, this is memory chip this is ROM, and another memory chip is RAM. Okay. So, this is also memory chip. Right. So, what I said, this microprocessor cannot store information or data, but this microprocessor needs access to a great variety of information or data, right, and those are such as, so microprocessor needs access to a great variety of information or data essentially to take the decision, right, and those information or data such as specifications, formulas, etc., right. So, now what we can see, these information or data are stored in these two memory chips, one is RAM, another is ROM. So, what is RAM? RAM, that is random access memory. Random access memory, while ROM is read only memory. So, these two are the memory chips which are there with the microprocessor to store information or data. Now, as microprocessor cannot store information or data, but microprocessor needs some information to take a decision based on the inputs, essentially those are electrical signals. So, microprocessor should have a provision to get some information or data which are nothing but specifications, formulas, etc., etc. So, now these two chips, as I told you that let us now discuss about the difference between these two. So, RAM and ROM. So, difference, what are the differences, right. So, these memory chips may be volatile or non-volatile. What does it mean? Let me write here. So, if we go to the next slide, memory chips may be volatile or non-volatile. Okay. So, if we go to the next slide and let us discuss or elaborate more on this, right. A volatile memory stores information as long as battery is on, battery power is available to it, right. So, let me write a few characteristic of this particular memory chip, that is RAM and ROM, and that is why we are first writing what is a volatile memory, because memory chips may be volatile or non-volatile. Volatile memory is that it can store information as long as battery power is on, right. So, this is, and the keep alive memory, the keep alive memory, this is also known as KAM, is a volatile memory. Right. So, if the power is lost, that power is off, battery power is off or battery is charge is low, then all information will be lost, right. So, this is the volatile memory, right. So, all information in it, in the memory chip, will be lost if the battery is disconnected or battery charge is low. A non-volatile memory, on the other hand, you can understand from the definition itself, is ROM, read only memory. So, if I write here non-volatile memory is ROM, read only memory, and so it is reverse, and the information stored in it and the information stored in it is not lost even when battery is disconnected. So, this is the non-volatile and volatile memory, I mean the difference between volatile and non-volatile memory chips. So, now let us discuss about briefly about the read only memory, and then we shall discuss about random access memory. So, another important salient point of this memory chip, that is ROM, let me write that particular salient point, then we shall discuss. So, if I write in a bullet point that some ECUs have removable chip called programmable read only memory, programmable read only memory, in short PROM. So, this particular ECU have chip, memory chip, which is already programmed with programmable chip. So, now, but the question is, the program cannot be altered. Once the chip is programmed, the program cannot be altered. If we need to change the PRM, we can change, which is programmed differentially. So, that is important. So, once programmed, so let me write once programmed, a PORM cannot be changed. However, it can be replaced by another PROM which has been programmed, differently. Let me write the most important point of this particular chip, that is ROM, and that is what I will be writing here. The microprocessor will look at the information from the engine sensors and compare or them, compare it or them, you know, to the read only memory data to make a decision on what to do next. So, this is very important, just I am trying to kind of put it in a box, that this is how microprocessor tries to read data from memory chip. So, it will look at the information from the engine sensor. Essentially, ECU will receive some input from the sensor. Those sensors will be the input to the microprocessor, and microprocessor on receiving some input from the sensor, engine sensor or sensors, they will receive some input and then compare those information or compare that particular information to the ROM data, because in ROM there is already some program data, some stored data, and then compare and then we will take a decision what to do next. Okay, fine. So, now let us look into another important type, that is random access memory. Or RAM. So, if we go to the previous slide, so yes, here random access memory. So, let me again write a few salient points of this particular memory chip and then we will discuss. So, I am writing again these salient points in the bullet form. The first point is the RAM or random access memory stores information temporarily, as long as the ignition key is on. As long as the ignition key is on, the microprocessor can read information. Let me write the second bullet point. The microprocessor can read information from the RAM and then erase and write new information in it. So, microprocessor can read information from the RAM and then erase and write new information in it. So, basically you know that RAM will store information temporarily as long as the ignition key is on, right, and then microprocessor will store can read information from the RAM and then erase and write new information. So, that is how it works. Okay. The next salient points, if I write here, the RAM stores information from the sensors, the results of from the sensors, the results of calculation and other data that continually changes, right. So, the last important point that I will write about this sensor, about this chip is, when the engine is turned off, RAM data is erased because it will not be of any use, because it will not be of any use, the next time the engine is started. Okay. So, the last point is very important, because you know that if engine is turned on. So, if we go back to the previous slide, we have written that RAM will store information temporarily as long as the ignition key is on. So, when the ignition key is on, that is engine is in on condition, then RAM will data temporarily, you know, and then microprocessor can read information from the RAM and then erase and write new information in it. So, engine is running. So, continually it will read, microprocessor will read information from the RAM and then erase and write new. If go to the next slide, RAM stores information from the sensor, the result of calculation and other data that continually changes. So, that means you know random access memory, that is randomly you can access, the microprocessor can have access to this data randomly. So, it will continually it will change continuously. Now, when the engine is turned off, then RAM data is erased, because it has no meaning of storing the data, and the data will not be of any use in the next time as the engine started. So, this is all about two different type of chips, memory chips, which are very important for the microprocessor functioning, and microprocessor is an important element for the ECU. So, now let me tell you one thing, that we have studied about sensors, and we had seen that typically input to the sensors or a sensor is physical variable, right, and output from the sensor is an electrical signal, and that electrical signal will go to the microprocessor, and microprocessor will give some decision to the ECU what to do next. So, the signal that comes out from the sensor or sensors is either analog or digital. Now, typically you know for the modern engines, digital circuits, digital signals are replacing the analog signal in the electronic control or electronic automotive system. So, the difference between analog and digital signals is very important to know for the electronic circuit which are typically used in the ECU. So, I will discuss this particular part very it is very important to know, because without knowing about analog and digital signals we cannot go for further discussion on electronic circuits, but there is an important difference between these two signals, analog and digital signals. It is recommended that we shall start our discussion with the analog signal, because it is very intuitive to understand the analog signal, because digital signals are more complex to understand, but we shall discuss about this particular topic, that is the analog signal and then digital signal and the difference between these two in the next class. So, with this I stop here today, and we shall continue our discussion in the next class. Thank you.